Hi guys, today we are going to be solving a system of linear equations in 3 variables, and we are going to solve it by elimination. To solve a system of linear equations by elimination, we need to go ahead make sure that each equation is in standard form. If we had equations in 2 variables, then the standard form would be ax plus by equals c. And if the system would have a solution, then it would be an ordered pair solution. But in this case, we are working with systems of equations in 3 variables. So standard form would not be ax plus by, but you guessed it, it would be ax plus by plus cz equals d. In English, a standard form, what that means, you want variables on one side, constant on the other. Now, if our system in 3 variables has a solution, what would the solution look like? It wouldn't be an ordered pair, it would be an ordered triple. Why? Because we got 3 variables. Okay, so let's do this. So to solve a system of equations in 3 variables by elimination, our first goal is to make sure that all the equations are in standard form. We have x, y, z equals constant, so we're good. So now we are going to make 2 pairs of equations and eliminate the same variable from each pair. So it doesn't really matter which variable you decide to eliminate. Our work could look different, but we'll get the same answer. In this case, I noticed that the coefficients on these are almost opposites. So I'm going to go ahead try to eliminate z. So let me go ahead speak to myself. So I'm going to say, let's go ahead pair equation 2 and 3. And let's go ahead write that, and we'll set up our other pair. So we have 2x minus y plus 2z equals 11. And equation 3 reads x plus 2y plus 2z equals 6. And then let me go ahead set up the other pair. So we're going to pair 2 and 3, and then we're going to pair 2 more equations. Bear in mind that we have 3 equations. So when we pick 2 and we're going to do another pair, we're going to have to recycle one of those 2 equations. So it's okay. So we haven't used equation 1, so for sure we have to use equation 1, and then you're going to pair it with whatever you want. You know, you could pair it with equation 2 or pair with equation 3. I'm going to pair with equation 2 for the simple fact that they're neighbors, and it will minimize the likelihood of me not copying it over correctly. But if you're like, no, this third one catches my eye because the numbers look a little bit smaller, then go for it. But we don't have time to do it all the different ways. So let me go ahead write pair 1 and 2. And that will give us 4x plus 5y plus z equals 6. And then equation 2 reads 2x minus y plus 2z equals 11. Okay, so I forgot which variable we were trying to eliminate. We were trying to eliminate z. The coefficients should be opposite. They're not quite. Let's make the bottom one a -2. So if we choose to make the bottom one a -2, let's go ahead and multiply both sides by -1. And our new system will be, the first equation was already perfect. The second equation, after we distribute the -1, that will give us -x minus 2y minus 2z equals -6. Let me check my signs because it just takes a single mistake for all of it to go down. Okay, I think we nailed it. A reminder, we were trying to eliminate z. The coefficients are opposite, so let's go ahead add the equations. So that will leave us with x minus 3y equals 5. And at this point it's like, oh, okay, I can breathe. Okay, so how do we solve a system of equations in 3 variables by elimination? So one, you're gonna pair 2 equations, make another pair, and eliminate the same variable. Okay, from the second pair, we want to eliminate z. The least common multiple between 1 and 2 is 2. So we want to get a +2 and a -2. Let's go ahead and multiply the top equation by -2. So when we multiply the top equation by -2, that will give us -8x minus 10y minus 2z equals -12. And the bottom equation was perfect as is. Alright, let's do this. So let's go ahead verify that the coefficients on the desired variable are opposite. They are. So we can proceed to add the equations to eliminate the desired variable. So the z's cancel out. The sum of the x's will give you negative 6x. The sum of the y's will give you negative 11y. And the sum of the constants will give you negative 1. Okay, so let's go ahead and do this. What we are going to do, we're going to go ahead create a new system by taking these two equations that we just found. So let me go ahead write new system. I think I said new equation, sorry. So we're going to go ahead create a new system by taking our leftover equations. So we have x minus 3y equals 5, and then we have negative 6x minus 11y equals negative 1. Okay. So at this point, we're going to focus our energy in this new system in two variables. This system has the variables x and y. So our mission is to first find x and y in any order, and then worry about finding the value of z. At this point, you can solve it by substitution or elimination. I'm a little biased towards elimination, so we're going to do elimination. So which one should I eliminate? This is how it goes down. If we wanted to eliminate the x's, the least common multiple between 1 and 6 is 6, so I will be working with 6's. If we wanted to eliminate the y's, the least common multiple between 3 and 11 is 33. So I'm like, okay, do I want to work with 6 or do I want to work with 33? Yeah, it's a no-brainer. We want to work with 6, okay? So let's go ahead and eliminate x. Least common multiple between 1 and negative 6, if between 1 and 6 is 6, so we want to get a positive 6 coefficient and a negative 6 coefficient. We already have a negative 6 coefficient. We just need to work on getting this positive one look like a positive 6. And that's an easy fix. Let's go ahead and multiply it by 6. Okay, but of course we can't just multiply that term. We're going to have to multiply the entire equation. Okay, so when we distribute the 6, that will give us 6x minus 18y is equal to 30. And the bottom equation was perfect. Negative 6x minus 11y is equal to negative 1. Let's verify that the coefficients are opposite. So let's go ahead and add these bad boys to eliminate the desired variable. So when we do, that will leave us with negative 29y is equal to 29. And how exciting! I thought we were going to have a fraction. Okay, we isolate the y. So to get rid of the times negative 29, we divide both sides by negative 29. And that will give us y equals negative 1. So again, we are focusing our energy on our new system, you know, the system that has x and y variables. So we found y, now we need to find x. Let me go ahead and speak to myself. Find x. So let's go ahead pick any of these equations. I know we have like love notes right here, but the one that scares me least is the original top equation. So let's go ahead use that. We have x minus 3y equals 5, and we know that the value of y is negative 1. So we have x minus 3 times y, which is negative 1 equals 5. Product of negative 3 and negative 1 is 3. To finish it off, after we subtract 3 from both sides, that will give us 2. Okay, so we found the x and we found the y, which were the variables in our system in two variables. Now we have the green light to find z. Okay, so how are we going to do that? We're going to take any equation that has the variable c. It could be any of the equations. Let me go ahead and project them. Okay, so which one should we pick? Whichever one scares you the least. I think I'm gonna pick this one. Okay, why? Because it has the smaller numbers without negatives. So I'm gonna go ahead pick that one. So the number 3. Okay, you're just gonna have to trust me that I copied it correctly. So the third equation reads x plus 2y plus 2z equals 6. We want to find z, so we have to plug in the value for x, which is 2, and the value for y, which is negative 1. Okay, so we did it. Let's make sure we don't have an arithmetic mistake. So we have x, in this case it's 2, plus 2 times the y we just found of negative 1, plus 2z equals 6. So that will leave us with 2 minus 2 difference of 2 in itself is 0. And after we divide both sides by 2, that will give us 3. So check it out. We found an x, we found a y, we found a z. So this system definitely has the solution. Remember, it needs to be in order triple. Okay, so x is 2, y is -1, and z is 3. If you just box this, I'm gonna cry because you did all the tough work. You just don't like getting full credit. Okay, so what we're gonna do, we're gonna go ahead wrap it up, because without the parentheses, it's not an order triple. It's just a list of things, you know, like a grocery list. You put parentheses, just like magic. It's an order triple or a point. Okay guys, so we're gonna do a grand total of, I think, 4 problems or maybe 5, I don't know. Okay, but we're gonna do 1 problem per video, because as you can see, it takes us a while. Thanks guys.